Welcome back to Tech Innovators, where we delve into the cutting edge of technology and software development. Today, we're exploring an exciting advancement in the realm of binary code and artificial intelligence, the LLM4Decompile. This pioneering project utilizes large language models to decompile binaries, a challenging field that could revolutionize how we understand and work with software. Now, to kick things off, let's unpack what decompilation really means. When we write code, it's compiled into binary. Think of it as converting a novel into a book of machine instructions. Decompilation, conversely, is like turning that book back into the original novel. This process helps us understand how programs operate, especially when the source code is not available. So why is this important? Well, decompilation can be crucial for security analysis, software maintenance, and even understanding old systems. Have you ever dealt with a legacy codebase that felt like reading hieroglyphs? This technology can help bridge that gap, making those ancient binaries more accessible. Let's dive into the specifics of LLM4Decompile. This open-source model is designed to take Linux x86-64 binaries and transform them into human-readable C code. That's like having a translator that changes complex encoded messages back into plain language. In its latest updates, the model boasts a 64.9% re-executability rate, which means a significant portion of the code produced runs correctly on the first try. That's a big deal in the tech world. Imagine the possibilities. Developers can analyze binaries to ensure they're secure and functioning as expected, or they can learn from existing programs. This tool isn't just a technical marvel. It opens doors for educational purposes too. If an aspiring developer could peek into the mechanics of existing software, it could greatly accelerate their learning curve. Now, here's where it gets really interesting. The LLM4Decompile model has various configurations, allowing it to handle different optimization levels, O0 to O3, during the compilation process. Each of these levels represents a trade-off between execution speed and code size. It's kind of like packing for a vacation. Do you take just the essentials or pack a few extra outfits for potential surprises? And speaking of surprises, there's the evaluation framework that assesses the quality of the decompiled code. They use a series of benchmarks, including a collection called Human Eval Decompile, which features functions requiring only standard C libraries. This means the model is not just spitting out code. It's being rigorously tested to ensure that what it produces is functional and reliable. So how does it work in practice? After pre-processing the C code into binary, it's disassembled into assembly language using tools like objdump. Through a sequence of prompts, the LLM4Decompile translates these assembly instructions back into C code. It's almost poetic, the way it weaves complex technical processes into something comprehensible again. Now that we understand this technology a bit better, let's think about its future. As the team behind LLM4Decompile plans to expand its capabilities, they are looking into integrating more architectures and settings. Perhaps it'll support even more programming languages and configurations in the future? That could lead to a much broader impact across the tech landscape. It's fascinating, really. With tools like LLM4Decompile, we're not just looking at code anymore. We're observing the evolution of how software is created, understood, and maintained. It's like watching an artist transform raw materials into a masterpiece. Before we wrap up, let's ponder this. What would it mean for your work if you could easily reverse engineer complex binaries or help others to do so? This kind of innovation could redefine norms in software development, make code more transparent, and possibly even